So unit 2, probability and distributions. Okay, so in the probability, basic definitions of probability and theorems of probability. Okay, important questions is good. Important questions. So in the second unit, we can expect one theory question and one problematic one. The theory question: discuss the concept and definition of probability. Explain the major theorems of probability. Explain the major theorems of probability is nothing but that is additional theorem and multiplication theorem for 2 and 3 events. Okay. The next theory question is: what is probability distribution? Explain the applications of binomial and Poisson distributions. Right. So these are the theory questions. Coming to problematic question: one compulsory practical problem on Bayes theorem or else probability. Right. And the next question: one compulsory practical problem on binomial, Poisson, normal distribution. Right. So now coming to probability. Here probability is nothing but the ratio between favorable cases and total number of exhaustive cases. For example, if I toss a single coin, okay, so we have two faces, that is head and tail, right? So my favorable case is head, right? Then here probability equals to, so number of favorable cases divided by total number of exhaustive cases. Here symbolically this is denoted by m by n, right? Here m equals to favorable case. My favorable case is only head, out of head and tail, that means only one, right? Out of number of observations are head and tail, that is 2, right? See here the important concept of probability is we have 3 axioms of probabilities, so very important for short note, right? So first axiom: the probability values lies between 0 less than or equals to probability of n less than or equals to 1. That means the probability values lies between 0 to 1 only, not exceeding 1 numerically. The second one is the total sample space that equals to 1. That means probability of success, that is denoted by P, and the probability of failure, that is denoted by Q, that equals to 1. Okay, so taken as example of coins, simple. Here probability of success is getting a head, right? 1 by 2. So similarly probability of failure is, that is also getting a tail, that is also 1 by 2, right? Then 1 by 2 plus 1 by 2, that equals to 2 by 2, that equals to 1. That means probability of success plus probability of failure, that equals to 1, right? So for example, throwing a dice, okay, in a single die total number of faces are how many faces? 6 faces. 1 2 3 4 5 6. For example, in this 6 faces, getting an even number is my favorable case, right? Now compared to 1 2 so on 6 values, what are the even numbers?
2 4 6,
right? So here my favorable cases are 3 out of 6, right? Here the probability value is 1 by 2, right? So similarly, for example, take it as example of playing cards, right? In a standard pack of cards, totality is 52. So in that we have 2 colors, that is, what are the colors? Black and red. So again segmentation in black, so we have again 2 colors, 2 signs, that is club and spade, right? In red, diamond and heart, right? So 13 13 13 13, this 13 plus 13 26, 13 plus 13 26, 26 plus 26 52. So for example, so in a standard pack of cards, okay, so getting a red cards is my success, right? Only red cards. Then what is the probability? My favorable case is only red cards. That means in a standard pack of cards, total number of red cards are 26 out of
52.
Then 26 by 52, that equals to 1 by 2. So this value lies between 0 to 1 only. So for example, in a standard pack of cards. So getting ace is my success, only ace, right? So here in 13 cards, numerical values 1 to so on 10 values, and alphabetical order jog, queen, king and ace, right? So 1 to so on 10 cards, right? That is 9, 10, 11, 12, 13. So total number of cards are 13. Sorry, it's 2 to 10 and jog, queen, king and ace, right? So here getting a ace is my success. In 13 card, 1 ace, in spade 1 a, diamond 1 a, odd 1 a. The total number of ace are
4.
out of
52.
so here 4 by 52. Okay, so similarly, for example, getting a spades is my success. Then what is the probability? Only spades. What is the probability? 13 by
52.
right. Here only spade cards are 13, then 13 by 52. So this is basic concept about probability, right? So now see the problems. The first problem, what is the probability of leap year to have 52 Mondays and 53 Sundays, right? So in a leap year, total days are 365 plus 1, that is 366 days, right? So a leap year consisting of 366 days, that means 52 into, right? The 52 weeks, that means 52 into 7, that equals to 364 plus 2 days. Is it clear? So that is known as leap year. Here, these 2 days can be following 7 ways, either Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, Sunday and Monday. But we need only
53 Sundays.
52 Mondays and 53 Sundays. Here, the total number of possible cases. So how many cases? 7 cases. So number of favorable cases to E, that is Saturday and Monday. So we need only Saturday and Sunday, right? Saturday and Sunday is our favorable case. Okay, so here we have only 1 case, then 1 divided by 7. Is it clear? So this is about the basic problems of probability. Now coming to theorems of probability. So we have 2 theorems, that is additional and multiplication theorems, right? So additional theorem for 2 events. Here, if A and B are 2 events, okay, so mutually exclusive and exhaustive events, then the sum of the events, that means probability of A union B, sum means union, that equals to probability of A plus probability of B. Okay, so next is, if it are non-mutual exclusive events, then the formula is probability of A union B equals to probability of A plus probability of B minus probability of A intersection B, right? For example, 3 events for mutual, A union B equals to P of A plus, so P of A plus, P of B plus, P of C. For non-mutual for 3 events is P of A union B union C equals to P of A plus, P of B plus, P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. So these are the formulas for additional theorem for 2 events mutually, non-mutually, for 3 events mutually, non-mutually, right? Union, A union, B union, C, right? So next is multiplication theorem. Now coming to problems on additional theorem. So this is very important, okay, in unit 2. So these are the problems. What is the probability that a card drawn at random from a pack of playing cards may be either queen or king. Right, here let S be the sample space associated with the drawing a card. The total number of cards are 52 C1, that equals to 52. Right, so in that queen or king, right, in a standard pack of cards total number of queens are 4, kings are 4. Right, so let E1 be the event of card drawn being a queen. Right, n of E1 equal to 4C1, that equals to 4. Right, so let E2 be the event of card drawing a king. Then n of E2 equals to 4C1, that equals to 4. Right, but E1 and E2 are mutually exclusive event. Right, so there is no common point. Actually mutually means there is no common point. Okay, so non-mutually means there is a common point. Okay, that is a variation. Okay, so here queens are different, kings are different. Is it clear? Then we need to use mutually exclusive event formula for additional theorem. Right, here since E1 union E2 is an event of drawing either queen or king, we have probability of E1 union E2 equals to probability of E1 plus probability of E2. So that equals to n of E1 by n of s plus n of E2 by n of s, that equals to 4 by 52 plus 4 by 52, that equals to 2 by 30. Right, so similarly, so next problem, so same process. So in a group there are 3 men and 2 men. So here men's are different, women's are different. Okay, genders are different. Right, so now 3 persons are selected out of 5. That means out of 5 persons we need to select only 3 persons, right, at random from this group. So find the probability that, so in the 3 candidates, sorry 3 persons, right, so 1 is men, 2 is women, that is the first condition, and the second condition is 2 men and 1 woman are selected. Okay, so now let S be the sample space associated with the selection of 3 persons out of 5. So n of s equals to 5C3, that equals to 10. So here 5C3, so here the formula is NCR. What is the formula? N factorial by n minus r factorial into r factorial. The same process ma, 5C3, so in the place of n is 5, in the place of r is 3. So here 5 factorial divided by 5 minus 3 factorial into 3 factorial. So 5 factorial can be written as 5 into 4 into 3 into 2 into 1. So 5 minus 3 is 2 factorial. 2 factorial can be written as 2 into 1. 3 factorial can be written as 3 into 2 into 1. So 3 into 2 into 1, 3 into 2 into 1 gets cancelled. 2's, 5 2's, 10. So this is the value. Right? So similarly, let E1 be the event of selecting 1 man and 2 women. The first condition, 1 man and 2 women. Right? So total number of men are 3. So in 3 men we need to select only 1 man. Right? So total men of women are, so out of 2 we need to select 2 persons. Right? Then n of E1 equals to 3C1. Out of 3 we need to select only 1. So out of 2 we need to select 2. Then 3C1 into 2C2. Then let E2 be the event of selecting 2 men and 1 woman. Right? The second condition, n of E2 equals to 3C2 into 2C1, that equals to 6. Here, but E1 intersection E2 is null set, that means 0. Here men's are different, women's are different. Then there is no common point. Therefore, E1 intersection E2 is null set, that means 0. Here this is also mutually exclusive event. Here P of E1 union E2 equals to P of E1 plus P of E2. Then P of E1 equals to n of E1 by n of s plus P of E2 equals to n of E2 by n of s. That is n of E1 is 3C1, 3 by n of s is 10. Similarly, n of E2 is 6, right, divided by 10. We get 3 plus 6 is 9 by 10. 9 by 10. So this value lies between 0 to 1. Right? So next. So now mutually problems are completed, right? Now coming to non-mutually exclusive and exhaustive problems. Right? So here the difference is, a card is drawn from the well-shuffled pack of cards. What is the probability that either spade or an ace? Either spade or an ace. So here, what is the difference between mutual and non-mutual? So mutual is, there is no common point. There is no intersect point, right? Now non-mutual means there is a common point. In a spade, there is a ace, right? In 13 cards, there is a ace. There is a common point actually, right? In the previously, kings are different cards or queens are different cards. Okay, in this problem, in spades, there is a ace. In spades, there is a ace, right? So here, let A denotes the event of getting spade and B denotes getting ace, right? Then A union B, the event of getting spade or an ace. Then A intersection B is the event of getting spade and an ace, right? Here, P of A, the total number of spades are 13 out of
52.
so total number of ace are 4 by
That's 52.
intersect. In 13 cards, only one ace, right? So that is probability of A intersection B. That is 1 by 52. There is a common point is occurred, right? By using non-mutually exclusive and exhaustive event formula for two events. That is probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. So that is 13 by 52 plus 4 by 52 minus 1 by 52. So 13 plus 4 is 17. 17 minus 1 is 16. 16 by 52 is 4 by 13. So 4 by 13 value lies between 0 to 1. Right? So this is about non-mutually exclusive events. For example, 3 events problem. From a city, 3 newspapers named as A, B, C are being published. A is read by 20%, B is read by 16%, C is read by 14%. Both A and B, that means both A and B. So that means A intersection B, both, right? That is 8%. Both A and C, A intersection C equals to 5%. Both B and C, B intersection C is 4%. And all 3, that means A intersection B intersection C equals to 2%. Then what is the percentage of the population that read at least one paper? Right, here given P of A equals to 20%, 20% can be written as 20 by 100. So P of B is 16%, that is 16 by 100. C is 14%, 14 by 100. And A and B both read 8%, 8 by 100. A and C both read by 5%, 5 by 100. B and C 4, 4 by 100. A, B, C altogether 2%, 2 by 100. So here the formula is A union B union C equals to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection A minus plus P of A intersection B intersection C. Just substitute values, we get 35 by 100 out of 100 population, right? So percentage means we need to take 100 peoples, right? Then 35%, that means 35 by 100 into 100, that equals to 35. Here the percentage of population that read at least one paper is 35. Is it clear? So this is about 3 events, right? So these are the basic problems of additional theorem actually. So now coming to, so here very important concept base theorem problems. So in this unit compulsory base theorem problems are compulsory. Okay, so now coming to base theorem. So this is statement, this is a proof, right? So here E1, E2, so on, En or N mutually exclusive and exhaustive events such that probability of Ei is greater than or equals to 0, here I equals to 1 to so on N. In sample space S and A is any other event is S intersecting with every Ei, right? So here if E1 is any event, E1 into E2 so on En, and where probability of E1 so on En, here our condition is probability of A given E1, probability of A given E2, so on probability of A given En is known, right? Here the base theorem formula is probability of Ek by A, or else simple probability of E given A, that equals to probability of E into probability of A given E divided by summation probability of Ei into probability of Ai by Ei, or else this can be just extended probability of E1 into probability of A by E1 plus probability of E2 into probability of A given E2 plus so on plus probability of En into probability of A given En, right? So this is a proof. So now coming to problems, very important. a bag A contains 2 white and 3 red balls, and bag B contains 4 white and 5 red balls. One ball is drawn at random from one of the bags and it is found to be red, right? So in this problem we have two bags, that is denoted as A and B. In A we have two colors of balls, that is white and red. Even B also two colors of balls, that is also white and red. So in that, in two bags, right? So we need to select only red balls, right? So that too in bag B, right? So that is a condition, right? So here we need to assume here only two bags are given, right? Then probability of A equals to 1 by 2, probability of B equals to 1 by 2. We need to assume. For example, 3 bags are given. Then what is the probability? P of A equals to 1 by 3. P of B equals to 1 by 3. P of C equals to 1 by 3. The total of the probability equals to 1. That means 1 by 2 plus 1 by 2 equals to 2 by 2, that equals to 1. Similarly, 3 bags are given. Then 1 by 3 plus 1 by 3 plus 1 by 3, that equals to 3 by 3, that equals to 1. If at all 4 bags are given, that is 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, that equals to 4 by 4, that equals to 1, right? So in this example we have only two bags, that is A and B. So here we need to assume P of A equals to 1 by 2, P of B equals to 1 by 2. So here red balls is given, right? So R is denoted as, capital R is denoted the event of drawing red balls, right? So here having selected bag A, the probability of drawn a red balls from A. So okay, so in bag A, if we select only red ball, the total number of bag A balls are 2 plus 3. The total number of balls total is 5. So out of 5 we need only red balls. So what are the red balls? That is 3. Then 3 by 5. So similarly, probability of R given B, right? In bag B, total number of balls are 4 white and 5 red. That means 9, right? So in that we need only red balls. Red balls are, here the probability is 5 by 9. Okay, so by using Bayes theorem, okay, so one of the bag is selected at random and from it a ball drawn at random. It is found to be red. The probability that selected bag B, right? Here the formula is bag B, saying that red ball. Then probability of B given R, that equals to probability of B into probability of R given B divided by probability of A into probability of R given A plus probability of B into probability of R given B. That means, so this is our favorable case. That is, bag B is our favorable case out of bag A and bag B. Is it clear? Okay. So for example, in the place of B, if at all A is given, right? Then what is the formula? So probability of A given R equals to probability of A into